Okay, so in problem 9A10, they gave us an odd number and then asked us to divide the team into even fractions. This problem asked us to do the first two learning outcomes. And as you can see, I used two different strategies in Tangent to answer the problem. I set up the problem in an organized fashion using the fractions. I need a half. So I have what I started out with. I have 25 players. I need a half infield and outfield, 1/4 starting pitchers, 1/6 relief, and 1/8 catchers. So I wrote down everything that I needed to know, what I already knew, which was this. And then I did the math and I decided that going through with the division and the fractions and everything, I decided how many infield, outfield, pitchers, and catchers I would need from those actual standpoints. So I believe that with this problem, one needed to actually set up the problem with all the necessary numbers because it's a complex problem that could easily get taken out into left field. I actually used three different methods of solving the problem for this one. I used division of whole numbers into fractions while rounding down. So I used 25 over 1, which is a whole number, and I found half, but then I actually rounded up or rounded down because I can't have half of a person. I mean, if I had to pick, I would probably want the top half because, you know, you can throw in catch with the top half, but it would probably get really messy with all that blood on the infield. So the third method that I used was subtracting each number individually and then checking my work by adding them back up together. So I did 25 divided by 1/2, which equals 2.5. And so then I did 25 minus 12. I did 13 divided by 1/4, which equaled, well, 3 point something. So it added 6. So then I took the 6 away from that. Then I had 7. Then I took 1/6 away from that. And I got 4. Then I had 3 left. Then I took 1/8 away from that. And I had all 3. So, but then I actually had to go back and I said, okay, I have 7 and 5 and 6 and 4 and 3. Those are my numbers for the team. And then I just wanted to make sure that I had 25. So this problem could be incorporated as multiple different standards. So for example, standard 7EEB3 states solve real life and mathematical problems using numerical and algebraic expressions and equations. Problem 6EEC9 states use variables to represent two quantities in a real life problem that change in relationship to one another. Write an equation to express one quantity, though thought of as the dependent variable, which the dependent would be our fractions because this is our independent, the 25, but our independent actually changes throughout the whole problem. Thought of as a dependent variable in terms of other quantity thought of as the independent variable. 5th grade is where you really get into fractions, and this problem is no exception. The first one being Common Core State Standard N.FF.A1 stating add and subtract fractions with unlike denominators by replacing given fractions with equivalent fractions in such a way as to produce an equivalent sum or difference of fractions with like denominators. So I could have turned this into 50 halves or 426, 52 fourths. So you can turn this problem into any fraction standard if you really need to. But I would not give this problem to a class of 5th graders because they're just not, it's just above their level. But these are just examples of how multiple problems will work for multiple Common Core State standards. The last part of my reflection is up to you to decide if I was able to communicate the solution to the problem in an adequate way. I am much better at doing this with my voice than through typing, and that's why I absolutely love the video reflections because I can come across the way I truly feel I'm capable of doing. Though with this problem, I think I got caught up a little bit too much with the numbers and explaining instead of actually doing my reflection. So thank you for your time, and I hope you have a great weekend.